So we have about 10 minutes for our contact. I wanted to introduce you to our Belmont ARISS team. This team has created just about everything that we have done here today, and they have been working on this for months. Sana created the t-shirts that many of you guys are wearing today. Declan, Liam, Jordan, Alexandra, Brisa, Antonio, Sana, and Ariana helped write interviews, started interviewing students, and created a video to share some of what we've learned. Antonio also created many of our morning news space facts of the day that you guys have seen through the morning news with Ms. Gondak. Thank you, Ms. Gondak. Zakaya, Marsala, Vivian, and many others from our team also worked together to pick our questions for today. They started with 314 questions. They have narrowed it down to the 17 that we will be asking today. These students have been working all year long creating and planning for today. Thank you guys for your dedication and your hard work. I also want to introduce you to our Woodbridge Wireless Amateur Radio team. Our contact today will be taking place using amateur radio. And because of that, we've got 2 antennas that are up on the roof. I sent a picture to your teachers. You guys may have seen the 2 antennas that are up there. And they are here to help us with both radio systems that are also set up here. But I wanted to make sure that we said thank you to Larry, Rob, Gus, and Terry for getting everything ready today. This has been lots of work on the radio side as well. Thank you. Today, we're going to be talking with Dr. Jeanette Epps. This morning, you probably watched some videos about her. She grew up in Syracuse, New York, which is where Miss Maris and I are both from. She is an aerospace engineer. This means that she studied to design, develop, test, and operate vehicles that travel in air and in the space. We watched Dr. Epps arrive on the ISS at the beginning of March, about 3 months ago, and Dr. Epps will likely be on the International Space Station until we come back from summer break and we are back here at school. She's up there for a total of about 6 months. So looking at what we're going to be doing today, our contact is really a science experiment. We'll be using radio waves to communicate with astronaut Dr. Jeanette Epps. Like all experiments, we're going to need to be very quiet and pay attention to what's taking place. The exciting part of any science experiment is when we finally get the outcome that we expect. We get really excited. The same is going to be true for today. When we hear Dr. Epps answer our radio waves, we will know that our experiment has worked. This will be exciting, but we can't call out because we'll miss what astronaut Epps is saying. We will want to share our excitement, and you guys have already figured out some of it. This is sign language. This is sign language for clapping, because if you are deaf, you can't hear the sound, but you can see. So when we make contact, it will be very exciting. You are welcome to clap, but we're not going to say anything, because if we say something, we're not going to be able to hear what's going to be taking place. There is no visual that we're going to be seeing. We're only going to be hearing. So let's take a look and see how our contact is going to be working today. That's the video.
Hi, my name is Ruth.
And my name is Chris.
You must be pretty excited to talk directly with astronauts on the International Space Station today. While we're waiting for the space station to come over your portion of the sky, let's talk a little bit about how it's going to happen. Of course, Mission Control is in contact with astronauts all the time, using a big radio with lots of fancy equipment.
However, we're going to be using something very different today. We are going to use ham or amateur radio to talk directly to the International Space Station.
When most people hear the word radio, they think of a music radio station, but it's so much more than that. Radio actually refers to the unseen energy that transmits all sorts of signals using electromagnetic waves. At first, people learned how to send signals like Morse code, and then they discovered that you can send so much more, like data, computer signals, and even TV.
Maybe you don't realize it, but you use radio every day. Maybe you watched the TV this morning, or you texted your friends, or maybe even you check social media like Twitter or Instagram.
Let's travel back to space for a minute. Since the beginning of the space age, humans have sent many spacecraft out into the universe. These range from the Hubble Space Telescope orbiting the Earth daily, and the Curiosity rover exploring Mars. We've even sent a long-distance messenger, the Voyager 1, who has traveled outside of our solar system.
Whether it's capturing a great picture of a far-off galaxy or conducting experiments on the space station, radio has to do with all of these. And today, you're going to be using ham radio. Now you might be wondering, what exactly is ham radio?
Amateur or ham radio is a service and a hobby where operators can talk with people around their neighborhoods, their cities, their country, and even around the world. Amateur radio operators require a radio license from the government. They're not that hard to get. I have one. My call sign is KM4LAO.
And mine is KD8YVJ. Our call signs are a way of identifying who we are to other operators. This lets everyone know that we have the proper license to using the radios.
As amateur radio operators, or hams as we are often called, we can talk with others about basically whatever we want, often science or some new radio gadget that we are interested in.
Let's focus back to the space station and your contact today. Many of the astronauts and cosmonauts aboard the space station are licensed ham radio operators. That's why your operators today can contact them. The people here, as well as the astronauts, are licensed to talk to each other, and you are allowed to talk over to their radio.
For our conversation today, we'll need an amateur radio station on the ground, either in this location or somewhere else around the world. We'll also need a radio in the space station.
Anyone SS.
You can hear the calls coming. This is November Alpha 1 Sierra Sierra, the International Space Station, over.
On the space station, the radio transceiver is connected to an amateur radio antenna mounted on the outside. One of these antennas will be used today during our contact.
For our side of the contact, we need a good-sized antenna, a signal amplifier, something to make our signal stronger, and a rotator for turning our antenna. We have to keep our antenna pointed right at the International Space Station. And remember, it's moving across the sky and fast.
To aim the antenna properly, we need to track the path of the space station exactly. NASA uses complex systems to track the path of the space station and other orbiting objects.
The satellite tracking program we are using works out a complicated set of mathematics to provide the orbital location of the space station moment by moment as it moves through space. This information is sent into the computer that controls the antenna rotator, which moves the antenna to follow the space station. Maybe some of you have seen or worked with robotics. That's pretty cool stuff. And just like you can program a robot where to go, what to do, and how to get there, you can also program a computer to tell an antenna how to track the space station across the sky.
You know, it took a lot of planning to get this contact. Several weeks ago, the ARISS operations team had to figure out when the space station's orbit would pass over this location. Then, they had to talk with the planners at NASA's Johnson Space Center. The crew's time is pretty full, so they were able to find a time that could work for the crew members' schedules. Once they found times that would work both in space and here on the ground, the host organized this contact. And in just a few minutes, you'll be hearing and talking to the astronauts.
Well, it's almost time for your contact. It will be exciting, so good luck with it.
All right, as was mentioned in the video, this opportunity would not have been possible without the help from ARISS, which is Amateur Radio on the International Space Station. It is almost exclusively a volunteer organization. They've been connecting students with space since 1983, when ham radio was first brought on board on the onto the space shuttle missions. For the past 40 years, ARISS has been able to do amazing things with a very small group of powerful volunteers. Let's thank ARISS with our sign language. All right, let's see how our contact is going to be working. My team, you guys can stand up. Come on up. Go ahead, Vivian, you can start. Yep, go ahead and read it, it's fine.
In a few minutes, we will start trying to contact.
Go ahead.
In a few minutes, we will start trying to contact the International Space Station so we can start asking your questions. You will hear Liam say a few things. He will start by saying, NA1SS, this is KM for TIY calling for our scheduled contact.
Awesome.
NA1SS and KM4TAY are called call signs. They are used by amateur radio operators. This contact is being conducted by using amateur radio. And these call signs are basically the names of the people who will be talking to each other. NA1SS is the International Space Station, and KM4TAY is Mrs. Lamont.
In between Liam calling, you hear some static. This is important to hear because it helps us determine if we're in contact with our astronaut yet. If we only hear static, the ISS may be still too far away to hear us.
Once the ISS gets close enough to hear you, you will most likely hear them call back KM4TAY. This is NA1SS. I can hear you. Over.
Over is a keyword which will tell us they are ready to listen to us talk. Since we can't see each other, the only way we will know when one person is talking and also the other person can start talking is by using the word over. Once we start asking our questions, each question will end with over, so our astronauts knows that they can start answering the questions without missing anything else we are saying from our end.
The International Space Station is 250 miles above the Earth, and they are traveling at 17,500 miles per hour. This means the space station is moving very quickly, so we'll have less than 10 minutes to ask our questions. We'll all need to be very quiet so we don't have to stop asking our questions because there's too much noise here.
As we get close to the end of our contact time, Declan will make sure we have a chance to say thank you for our contact and goodbye. This means we won't get all of our questions answered, but we also want to make sure we can say thank you.
After our contact is over, we'll take one big school picture so our astronaut can see what we look like. We'll give directions when we're done. We are ready for Liam to start calling for our contact.
All right, we have just a few minutes. Our contact officially starts at 12:03. So what we're going to be looking at today is we're waiting for the space station because the Earth is round. We're waiting for the space station to come close enough so that our radio waves can reach them. So that we're not quite there yet. It's kind of like waiting for a car to come around the curve. The car hasn't come around the curve yet, so we're waiting for the International Space Station to come up over the curvature of the Earth. We won't be able to get in contact with them until they are basically in a line of sight with our radios. The space station is going to be coming from about this direction. So if you were to look out towards the playground, it would be coming up from the playground. It goes around this way and comes back down this way, down towards Belmont Bay. So we will have the whole time to talk with them. This will be going up to about 60 degrees, 61 degrees. My students that know angles, what angle is this? This is a right angle. A right angle, does anybody know how many degrees it is? 90. Okay, so 90 is going to be straight up. If this pass was a 90-degree angle, it would be going straight above our school. This one is about 61 degrees. So 45 is halfway between. 45 is here. So ours is going to be about here. It's going to be about 61 degrees as it passes from one side to the other. It will start going low. It'll get up to its highest point about here, and then it will start curving back down as it's traveling. So that's what we're going to be waiting for. As soon as it gets too far, it's going to be like the sun setting. So as the Earth moves, the sun appears to set. The space station is going to do the same thing. It's going to be coming all the way over here, and then it's basically going to disappear below the horizon. So in order to call for them, we're going to be using our call sign, which is KM4TAY, and Liam is going to have to call this a couple times. On top of our roof, we've got two antennas. We're using one of them. The other one is a backup antenna. I don't know if you guys saw them on your information that we sent out, but the antenna is very big. Our antenna is going to be bigger than the antenna that's on the space station. The space station antenna is only about this big. That means that our signal is probably going to reach to the International Space Station before they can reach us. So what we want to do in order to make sure that we can hear all of our contact and we get all of our contact time with Dr. Jeanette, then we want to make sure that we can hear all of it. So Liam will start calling. We have 2 more minutes? 2 more minutes, okay. What that is called is AOS, acquisition of signal. Acquisition is when we're going to get it. LOS is loss of signal. That's when it's going to go away, and that's at about 12:13. So that's going to be about a 10-minute pass. We will probably not hear them at 0, and we will probably not hear them at 0. So we're going to hear them a little bit in between. Do we want to start calling, or are we still pretty early?
They're still below the horizon.
Okay, so they're still below the horizon. We will wait for just a minute, and then Liam will be ready. Do we want to test this, Mike? You're okay? All right. Come on over here. So this, I'm going to press it for you, and then you'll say NA1SS, this is KM4TAY. Okay? Do you want to, you can speak. Go ahead and say test, test. I'm not going to press anything yet.
Test, test. Test, test.
A little bit more.
Test, test.
Good. Keep going. Test, test.
Test, test.
Talk loud.
Test, test.
Okay, we're good? Yeah. Okay. We're just waiting for our radio team so that we are ready to call when the station comes up. That is the static. That's the static that you guys are going to hear. Oh, we are not talking, or we're not going to be able to hear everything.
NA1SS, this is KM4TAY calling for a scheduled contact. NA1SS, this is KM4TAY calling for a scheduled contact. NA1SS 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 is KM4TAY calling for a scheduled contact.
She's calling back, but we can't hear her. Okay, go ahead. Try again.
NA1SS is KM4TAY calling for a scheduled contact. This is Liam. We are excited to talk to you. We are ready for our first question. Over.
For Ayat. This is Arham asking a question for Ayat. What happens to sweat in space?
this is Leola. Do you ever get allergies in space? Over. This is Hira. How do you communicate with your family? Over.
Yeah, that's a great question. The same way I communicate with you, we can talk over the ham radio, but we also have software like Teams. We can call them and make them call us via Teams, and that goes through the satellites, and we can talk every day. So I miss them, but I can chat with them every day.
This is Noah. When you have free time, what do you do to pass the time? Over.
One of my favorite things to do is pass the time is to chat with students like you or chat with friends and show them the International Space Station, something they have never seen, or look out the window. The cupola windows have a great view of our planet, Earth, and so I can show them those things and describe what to do, get them excited about space as well.
This is Anna. What is your favorite thing to do in space? Over.
Like I said, is to chat with friends and family and introduce them to the International Space Station, show them the different modules, give them a complete tour of the space station. And, of course, looking out the windows up here. We have some great views of the planet.
This is Amy. Do you still have to learn Russian to be able to travel to the space station? Over.
Yes, you do. That is one of our requirements, that you at least reach a minimum level of at least intermediate mid or better. And so we have 3 colleagues here who are from Russia, and we all have dinner from time to time together. So it goes a long way to, if you fly in the Soyuz, you can read all the procedures, and also for camaraderie and friendship.
This is Gia. When you're sleeping in space, do you get claustrophobic or uncomfortable? Over.
Yeah, sleeping in space is just like sleeping on the ground. I don't get claustrophobic or uncomfortable. On the ground, if I get uncomfortable, I just roll over or something like that. So sleeping in space, even though you float inside your sleeping bag, is still very similar to sleeping on Earth. I actually sleep pretty well here in space.
This is Alina. When you are launched up into space, does your blood pressure feel like it goes up to your head like on a roller coaster? Over.
When we launched into space, I felt like it was a roller coaster ride, but I didn't feel the fluid shift in my body until I got to the space station. And once I set foot in the space station, you could start feeling a little bit of it, but not really. So it's unlike anything that you've ever felt. But you do get a fluid shift in your body when you come to space, and you no longer have gravity pulling you down.
This is Declan. Can microgravity impact the human body in any harmful ways? Over.
Declan, in fact, we do a lot of exercise here because when you don't have gravity, your bones don't have a reason to, well, in general, it doesn't have a reason to grow. So gravity is a force that acts on your bones as an impetus to grow and grow denser. So we do lose some bone density and muscle, but what we do up here is we exercise every day. We do weightlifting, and we do cardio just about every day that we're here in the city.
That's our LOS. All right. Declan, why don't you come? Huh? Okay, go ahead. Go ahead, readers, sorry.
This is Alexandra. If you get motion sickness, how do you deal with that? Over.
This is Sophia. How was the change to life in zero gravity? Over.
This is Bella. When you were a kid, what was your dream job, and did you ever expect to be an astronaut in the future? Over.
This is Declan. Thank you so much for taking your time to talk with us. We really enjoyed talking with you today. Over.
Okay, so that's it. We got them all. All right. Thank you. Very nice job, guys. Yay. All right. My team, let's take one picture so that our astronaut can see us. My team, come on back up. All right, you ready? You guys are welcome to hold up your hands so that you can wave. 1, 2, 3. Awesome, thank you.
All right, Belmont Eagles, let's give a big round, a silent round of applause to Dr. Lamont and the space crew. Silent there.